Okay, you can start now.
Okay. So first of all, good morning, good afternoon, and hopefully good evening, everyone. This is Wang again from China. So it's my second time to represent this kind of technical presentations from the IWA water loss specialist group, the webinar series. So first of all, I'd like to thank Gary and Stuart to give this opportunity. And to whom don't know me, my formal Chinese name is Yuxi Wang, and I'm currently one of the young water professionals from the IWA water loss specialist group. So 2 years ago, if any of you ever pay attention on the IWA YouTube channels, 2 years ago, I already gave a presentation on the acoustic leak detection and also the active leak control in China. So today I'm going to say something different, and I'm going to say something about the noise logging technology that we developed in China in the last couple of years. So let's go. So the whole system is called the TAN logger, and TAN in Chinese means detect. So you can tell from the name of the logger, we don't only alarm the leaks. We're also trying to find the leaks or detect the leaks from this kind of logging system. And the TAN series logger, it's based on two prospects. One is the AI technology, and also the other one, as everybody will be familiar with, is the wireless, the NB-IoT communication technology. So we basically combine those two technologies to provide continuously monitoring the water supply mains. And apart from that, we also have a different mode to meet the needs of different countries and different working conditions. So we not only have the NB-IoT mode, the TAN logger can also compatible with 4G, LoRa, Cat1, and other versions. So we can simply insert this system into all different global conditions. And the next slides, I'm going to talk about the product features based on 4 points. And first of all, the entire system is fully automated, including the data collection, the transmission, and the analysis, and the leakage alarm. It's all done automatically in 30 seconds. And there's no human intervention about it. So when the system see a leak, they just send alarm and tell you where the leak is. So the data analysis conduct at least 3 times a day. If one logger does find one leak, the frequency will increase until it returns to a normal condition. And for the data collection frequency, it's also can be adjusted by the customer. If the customer think it's too much, or it's too many alarms from the mobile phone, they can switch to a less frequency for the data collection. And the most important feature of this TAN logger system is the AI. So TAN logger basically implements the artificial intelligence technology in the leak monitoring. And we know that so far we have lots of remoted loggers from other brands, but as far as I know, there are probably less than 3 companies who are able to apply the AI algorithm into their logging system. So TAN logger system is one of them. So the AI prediction algorithm, it's based on 30 million leak data. And this number is it's keep increasing every day because the logger, they're not only hear the leaks or sending alarms and also recording the sound data. So once they recorded the sound data, they will keep it into the library, like the data library. So 30 million is only like the basic number of our data. It's getting higher and higher every day. The more loggers we deploy, the more data we receive from the system. So to illustrate even clearer to the audiences, I'm going to present 3 scenarios. The one is the situation where we have a there's a leak, and the second scenario we have a sound, but it's not a leak noise. It's just a noise, but it continuously making alarm. And the third one is the actual leak sound that the system can detect. So let's see the first scenario. So we have a sound, and then because the noise we usually hear from our ear and also from the loggers, if the leak sound, if the background sound is so different from the leak sound, or if the sound the logger here is not continuously making noises, then the system can easily detect, okay, this is not it's either a background noise or a actual leak sound. It's something maybe some cars driving by or some footsteps or something else. So the system can easily detect, okay, this is a normal condition. There's no suspicious sound that can make the loggers to sending any alarms to the users. And the second scenario, when we have a suspicious sound and the sound looks like it might be a leak, or it might be a background noise from the PRV or from the T-joint, then the system will automatically open the algorithm, the AI algorithm. And the algorithm is composed by, we call it a dual mode. So it's like 2 layers. And if the system detects a sound and they think, okay, this might be a leak sound, they will open the first layer of the model, and the analysis model. And when they trying to analyze the sound by the first layer of the model, and they found out, okay, based on the data we received from the past and also the calculations and analysis, the system think this sound is not a leak sound, but it might be something that from other situation, like what I said, like from PRV or from a T-joint or from some other situations. Then the system will tell the users that, okay, it's not a leakage. It's not a leakage. The sound is not from the leakage, but the sound might be from something else. But it will give you an answer that, okay, this is not leakage. And the last scenario we will see, and hopefully we see that system can work, is when we have a sound, and when it goes through the 2-layer model, and the system think, okay, the first layer think, right, this is a sound, and it continuously making the sound to the system. And the logger think, okay, it's continuously making a sound, and then we will go through the next level of the model, which is the even more accurate, more with a higher precision model to do the calculation and analysis and use the data from the library to match with the sound that the logger detect. And finally, they will think, okay, this is a actual leakage. So this is the third scenario that the system or the AI model can give us. So it's either a no sound or normal situation, or a sound that is not generated by the leak, or it's a leak. And to this, the next step we are going to discuss about is the logger itself. So the entire logger, which I will show you later from the PowerPoint, the design is very simple. It's like a all-in-one design. There's no switch. There's no external antenna. There's no accessories outside of the logger. It's just a simple thing. It's easy to install. Anyone can do it and can be done in 1 minute. So it just literally put the logger and put it on a pipe or any metal accessories from the pipe, and that's it. And also we have the app for smartphone to do all the recording, the data transmission and things like that. And the users will see what's going on from the app from their smartphone. So as I said earlier in the PowerPoint, it's the NB-IoT will provide the most reliability for the data transmission compared to 4G or other types of communication technology. And also it's a IP68 waterproof, so it's suitable for the humid environment. And the logger can work at least for 5 years due to its low power consumption design. So once you deploy it, you just leave it there and just keep monitoring every day and let the loggers to do their own work. Right, and the third part is the typical workflow. And I don't really want to talk too much on this part because it's actually the same workflow as every other loggers do. So deployment, we install the logger on the pipe, and it will be automatically turned on. And we suggest that the loggers deployed within the internal of no longer than 250 meters. And it actually depends on pipe materials too. Well, if you've got PVC or PE pipe, like those plastic pipes, you probably have to make it even shorter, maybe shorter than 50 meters or 30 meters, due to the sound propagation. It's very, very short on those plastic pipes. And once you deploy it and it's all turned on and that's it, then you open the GIS platform and open the app, they will automatically start recording the sound data. So if the loggers found something suspicious from the pipeline, they will give you an alarm, and you will see an alarm message from your mobile phone, and the engineer will go there and check. Okay, this is the area we will find the alarm. And you can see from the interface, we have alarm from a building, and we also have the type of the leak. It's a small leak or underground leak, or it's a leak from the manhole or something like that. And also we have the approximate leak rate from this place, and also the other informations from the loggers. Then when the engineer or the leak detection crew receive this message, they will send the people there and then start doing the normal workflow of the leak detection or the pinpointing workflow. And then finally we'll find the leak from this area and then job done. And then the next step, alarm off, and we will receive all the data from here and then let the system just continuously monitoring. So that's the 4-step workflow. It's quite simple. It's all automatic. So all you need to do is to just keep looking at the screen and don't miss the alarm message from the mobile phone. And as I said in the previous PowerPoint, it's all-in-one design, and the temperature for this small logger is from -10 to 60 Celsius degrees, and the battery life is over 8 years. And we have already made the English platform. It's not only in Chinese. We also considering the customers from the Western world. We already have the GIS platform all in English. All the interfaces are translated into English. And so from the platform, you will see a map. You have the historical record, and also all the loggers you see from the map, and all the status from each logger, if it works normal or there's alarm on loggers. So the next, we will talk about 3 case studies for this 10 logger. So the case study 1, I'm going to do it from 2021 to last year. Okay, so the case study 1 is one water utilities from Tsingtao. It's called the Chengyang Waterworks. And so it's quite a big company. They are controlling 6 water plants, and the data supply is about 187,000 cubic meters, and they have 620 kilometers of water supply network, 26 kilometers of water mains, and 596 kilometers of water service pipes. And their NRW is very high. It's about 30%. And maybe some guys know that we just released a new regulations in China about the urban water leak rate has to be controlled with an 8% by the year of 2025. So obviously this company is far away from the standard. And we calculated the economic loss from the water leakage is about 45 million RMB per year. So it's quite a water loss to this company. So we signed a contract to them, and we're trying to enhance their supply mains from a very old-fashioned way to a smart water level within 2 and 3 years. Not only deploying the loggers, and also trying to build an entire smart water platform for the company. So in total, we have 5,000 loggers implemented into the system, and we will give them a visual platform to see all the loggers and all the status, and continuously monitoring by the NB-IoT mode. So 2021, in summertime, we started the phase 1 project. We firstly deployed 1,000 loggers, and it was quite fast to. It's only take about a month to deploy all the loggers, and we provided monitoring about 126 kilometers on water mains. And the project, it's been running for more than a year, and so far it's still running. And you can see from the platform, we have all these green dots, the loggers we have, and it's monitored in the buildings and on the pipes and water mains. And you can see the loggers is on the pipeline, and people trying to set up the transmission and such and such. So the result was quite obvious. We found 145 leaks in 1 year, and we saved about 7.45 million tons of water for the company. And the maximum leakage we calculated was about 30 tons per hour, and you can see that. So it was quite a big leak. And also, we have the report from the company and to calculate the leak rate, and also how it generated. So the case study 2, not only we deploy the loggers in the China mainland, we tried one case to Hong Kong Water Supply Department too. So we had like 167 test points deployed in 7 different areas in Hong Kong, including the commercial areas, industrial areas, and residential. And for this case, we also tried on the different pipe materials. We tried not only on the metal pipes, we also have PE pipes. And the diameter is from DN50 to DN700. So the test projects gave us 23 alarms. And we also tested the data transmission rate is about 98.7% for the NB-IoT. And we found 3 leaks, not as many as we found from the Tsingtao case. So for Hong Kong, we think that the 10 logger is okay for several pipe materials, including the cast iron, PE, and galvanized pipe. And also from DN50 to DN700, the loggers is able to detect the sound from those pipe range. So overall, we think that NB-IoT is applicable in Hong Kong. So we think if it works in Hong Kong, it should be worked in other areas. I mean, in European countries, or in America, or South America, and in other countries. And for the latest projects we have is last year in Huainan Waterworks. We deployed 250 loggers in 5 days by 4 engineers. So again, it's a quite quick deployment for this project. And we monitored 21.4 kilometers of the water mains. And also we have 2 carriers to provide NB-IoT service. Depends on the quality of the communications in different working areas. So in China, because the area is so big, and sometimes if one company cannot provide enough signal transmission, we will also use another company to provide a different mode. But in the end, the type of the data transmission is still under the NB-IoT mode. And in the first 6 months, we found 12 leaks, and we saved 1.6 million tons of water. So here is the results from the platform, and also you see the green dots again. They are the loggers. And so, right. That's very short presentations, but the whole point I would like to say is that in China, we're still trying to develop our own NB-IoT logging system. So as you know that China is in a quite fast speed on those Internet of Things and data transmission. So if any of you are interested in this, trying to give a test, a trial from this system, we are happy to provide that. So thank you.
Thank you very much, York. Interesting presentation. It's good to see that there is new technology coming out in the world that can challenge some of the sort of like more long-term suppliers that are out there. If anybody has any questions, they can ask them in the chat function. While we're waiting for questions to come in, I'm just wondering, in the the systems that you had in China and in Hong Kong, what sort of pressures were we looking at in the system?
So basically in areas which along the coastline, such as Tsingtao, the water pressure is always like 0.3 megapascal or 30 water meters. And for Hong Kong, I'm not really sure because I haven't received enough data from Hong Kong, but in a similar area like from Chongqing, you know, for those cities that in the mountains area, their pressure seems a bit higher than the cities in plain ground. So for example, for Chongqing, their water pressure is always like 0.4 to even 0.6 megapascal for the pressure. So they have lots of PRVs in Chongqing. So I think in Hong Kong it's probably the same or similar situation.
So have you ever used this system in some of the networks with much lower pressures, like below 20 meters?
No, we haven't, but we are trying to do it probably in Shanghai, because maybe you don't know that the Shanghai has very, very low water pressure. It's about, some areas it's below 0.2 megapascal. It's quite low. So it's also challenging to the leak detection crews. So to detect leaks, they sometimes have to use the pump, the gas pump, to increase the water pressure so that they can listen to leaks. It's a very old-fashioned way to do it. But in the future we will try to put more scenarios on those low pressure zones. And
you mentioned that in Hong Kong you were working on PE pipes. Does that mean that in China it's mainly metallic pipes?
Actually, in China mainland, we have it depends. In the bigger cities like Beijing, Shanghai, Guangzhou, or Nanjing, the percentage of metallic pipes are increasing. Especially on the ductile iron pipes, because we learn a lot from Japan and from Singapore and from the other countries who manage their NRW very well. So basically, we know that the DIP is good for water mains, and for the service pipe, we usually trying to invest more on the steel pipe, the SUS 304 steel pipe. But it's costs lots of money because the pipe itself is the price is very high. So for county level or small villages, we still use lots of PE pipes, and the PE pipes ranges from DN 100 to DN 450. So we have very big PE pipes, and for those PE pipes who is over than 250. The loggers cannot work really well, to be honest, because of the sound propagation. Again, it's very bad. It's very, very, very bad. We cannot do the correlation. We cannot use the logger, and so we use other ways. We try tracer gases. We use a smartboard, Sahara, or this kind of technologies trying to find the leak. But for small diameter, the loggers is okay, but still it depends. I'm not assuring that all the PE pipes can work, because PE and PVC is very tricky. So it always depends on the current the situation.
Okay. And probably following on from those two questions, we have a question from Stuart, which is basically, you seem to be putting loggers out every 100 meters, even on metallic pipes with good pressure. Why such short distances compared to normal noise loggers?
So the point, because the product were just released like a few years ago, so we were trying to calculate the exact amount of loggers on those diameters. So the case studies I present to the audience today is like the 3 trials with very complete data sets and for everyone. So yeah, I quite understand the storage question, because for normal loggers, for metallic pipes, probably you can only put 1 for every 100 meters. But still, as like I said, the pipe materials we have in China here, even for the metallic pipes, it works different. And underground soil condition is different from the rest of the world. And I'm not really discussing about the underground water level and also the background noise from the environment of China. And also the signal transmission of China is quite bad too. Like you have lots of buildings, we have millions of cars and other things in the air. So at the beginning, we're trying to put as many loggers as we can to test the real conditions for each scenario. So in the future, as in the aspect of users, of course, we're trying to save as more money as we can, you know, just maybe put 1 or 2 for every 100 meters. But for now, and in the future, we're still trying to test this scenario, like see which number is the best suitable for different pipes. So, you know, CIP, DIP, galvanized steel pipe, they all have different conditions and sounding propagation. So it's all depends. But I can totally understand why Stuart asking this question. Yeah.
Right. Okay. I noticed that you were talking about most of the trials were using NB-IoT.
Yeah.
I may have missed it, but is that the only communication technology you use, or do you use 3G, 4G, or anything like that?
Yeah, we use 3G, 4G, and we use LoRa. And well, I'm not an IT person, but they also have a CAT1, CAT1. I don't really know what that is, but yeah, 4G, 3G, all these the classic model of transmission that we use that. But you know, the 4G, and we also have 5G in China now, but still the signal sometimes we can't just receive it. So we rather are willing to build a small environment to gather the data and then we send to our server. So that's why we use the narrowband.
Right. Okay. It's just that there are some countries that I know in Southeast Asia, they haven't really developed NB-IoT too much at the moment. So they would need to rely on other communication
4G. Yeah.
And probably the key one for people that are watching outside of China is the platform. You showed the platform being in Chinese language. I assume that you have other languages as well.
Yes, we have English, and if the users want to use other languages, we also can try to build it in different languages. But yeah, the English, we will sure at least we have the English platform, and it's going to be very easy to follow. There's not so much things to read about it. You know, it just it's a visual platform, and you see things happening on the map. That's it.
Yeah. Okay. Well, thank you very much, York. We don't have any more questions, so I'd just like to say thank you for that presentation, and we will upload it onto YouTube soon.
Okay. Thank you so much, Gary, and thanks for the question, Stuart.